I'm Anusha Agnar from PQI, and today you're watching our PQI Profiles, a show in which we get to know our members. So today I'm joined by Vikesh Siddhu, who is from Physics Department at Carnegie Mellon University. Currently, he is a final year Ph.D. student working with Professor Robert Griffiths in the area of quantum information theory. Vikesh, welcome to our program.
All right, thank you.
And firstly, congratulations on winning the Poster Award at PQI 2018.
Thank you.
So, how do you feel about it?
I was quite happy actually because it's sort of, what should I say? It was something that most of the people at PQI were sort of in a very broad interest, and I was happy that the poster reached some broad set of people.
Okay, so I would like to know more about yourself, your family, and a bit more about your background.
Yeah, so I grew up in Delhi, back in India, where I really liked the street food, which is quite fun. And after doing high school there, I moved to do my undergraduate at an institution called ISA Mohali. It's about 5-hour train ride away from Delhi. There I did my bachelor's and master's in physics. However, we were taught different subjects and you could choose many things. I majored in physics. And then I came here for my PhD. Yeah.
Okay, so I was born in Delhi, back in India, so
Oh, nice.
I'm familiar with Delhi. So tell us about your research and what's the main motivation for you to take up physics in undergrad and as well as in PhD?
Well, in undergrad it was sort of by accident that I was trying many things, and this seemed to be the most fun thing that I was doing at the time as far as academics was concerned. And so I continued along, and then I became interested in quantum information theory even as an undergraduate. And after completing that degree and with some background in quantum information, I came to Carnegie Mellon. And there I became interested in our present research problem also by accident. It's just reviewing some literature and found something really strange and fascinating, and which essentially is that when you try to, say, send quantum information between two people, turns out that if you try to use some sort of channels for sending information, and they're useless.
Okay.
But if you use two of these useless channels together, you can get useful stuff out.
Really?
And the first time I saw this, it's very baffling. And so that's the question. That's the big question I've been trying to pursue for some time, and that's how I got interested.
Okay, so what are the major applications of your research?
Well, one of the applications of the kind of stuff I do is to basically help people who have to design, say, a network or a quantum internet, for example. How well will they be able to send and receive information? What's the limits on that?
Okay.
And a second kind of application of the quantum information theory research is sort of gaining more intuition about how quantum mechanics and its applications to information theory works. So there is the side where things are sort of practical and you compute some number which is useful, and there's also the side where you try to develop theoretical tools which are useful for their own.
Okay, so is your work like mostly theoretical or computational, or like are you an experimental physicist?
I am mostly, I would say, theoretical physicist, but in quantum information theory. And sometimes you have to use numerical tools once you sort of reach the tip of your theoretical abilities to compute something. And so I also do a bit of numerics from time to time. And sometimes I become interested in things like optimization theory and that, which is also fun.
Okay.
So there's a mix of both.
Okay, so I'm sure like being in PhD, it's not an easy ride. You definitely face challenges in your research. So when your research is concerned, like what are your like major challenges?
Yeah, I guess 97% of your ideas don't work.
Oh, okay. Okay.
So that's one challenge that you have to face. Well, but the other thing is you have to keep coming up with new ideas and trying them. And that's, I think, the major sort of difficulty that you have, is to kind of keep coming up with new ideas and improve on the ones that didn't work, and which is most of your ideas.
Oh, so how often like do you come up with the new ideas? Like what's like a typical duration?
there's no kind of duration. You just keep working and getting stuck, and
Okay.
you try clearing that up. Like 1 or 2 years later, you realize, oh, this is new.
Oh, okay.
But you never have this, oh, I have a new idea today.
Oh, so-
You kind of keep pushing it incrementally, and someday, eventually you see, oh, this is a bunch of new stuff.
Okay, I'm sure like 1 or 2 years is a long time. But like apart from like challenges, what is the most exciting and rewarding thing about your research?
When the ideas work.
Okay.
That day is very good.
Okay,
That's
so
a very good day.
So like, did you figure out like what ideas have worked so far in your favor and like what didn't?
Yeah, the thing is, you only come to know after you try them out.
Okay.
So before that, you don't know. So, and most of the ideas are sort of, let me try this theorem from that thing and apply it here, or wow, this looks like this algorithm will get stuck in that point. How can I sort of change things
Right.
so that it doesn't get stuck?
Right.
And then you try it on problems that are of interest to you. Or things like, oh, well, this phenomena is observed in that system. Now can I kind of doctor my system and see if it works here as well?
Okay.
Things like those. And sometimes they work and sometimes they don't. But
Okay.
yeah.
So I'm sure like that's really exciting thing to do. So like, you know, I'm an international student and I know like when I first came to US, like I did face certain challenges. So as an international student, what are the challenges that you faced in US like initially?
My main challenge was food.
Okay. Oh, I'm sure. Every student's major problem.
My main challenge was food. It's kind of, but thankfully the area around campus has quite a few food options. So I had to get through with that. The second sort of challenge was the weather, because
Oh,
I'm from
sure.
Delhi and I'm not used to the minus 10 Celsius that it sometimes happens, and even worse.
But Delhi is generally cold, right?
Yeah, not it. It really isn't when you compare it to Pittsburgh.
Right, that's true.
And but apart from that, I was pretty happy at the Carnegie Mellon community in general. It was sort of.
Okay, so you're like in your 5th year of PhD. So how would you describe your PhD experience at Carnegie Mellon so far?
I think it definitely has been a very enriching experience. There's a lot of interdisciplinary research that happens at Carnegie Mellon, and lots of various subjects sort of. It's easy to talk to researchers from different areas, and that really makes a good environment to exchange ideas and so on. So in that sense, I find it very fun. So while I'm trained as a physicist, there's lots of ideas in computer science and statistics and optimization that you pick up and you find use for in your own research and so on.
Okay.
And so I find my experience at Carnegie Mellon very enriching. Very sweet.
Okay, so like I'm sure being a grad student, you don't get to do a lot of like recreational activities or like be part of like other activities. But I would like to know what's your favorite pastime.
Since my major problem was food,
Mhm.
I decided I should fix that.
Okay.
So my major pastime these days is actually trying to cook food.
So it's been 5 years. Like, how well did you master it?
Not really.
Oh, okay.
But it's the one thing that I try to do from time to time. Apart from that, I just, drinking coffee, I guess.
Oh, really?
That's
Drinking
the-
coffee. Okay.
That's that I think consumes a lot of time for grad students. in
That's
general.
true. Like, I think I've become a coffee lover ever since I came to US. So, like, while growing up, everybody has an inspiration and, like, you look up to some people. So, it doesn't necessarily have to be related to your research, but, like, are there any role models in your life?
Yeah, not really. Growing up, I just didn't think enough,
Okay.
I guess, about these
Okay.
things. I mean, you had this question in high school where the teacher would ask you to stand up. What do you want to become in life?
Exactly.
And who is your role model? And my answer was usually no idea.
Oh, okay. Okay.
And that did go down very well in the classes, but it just
Okay.
never happened.
Okay. So, like, how would you describe your experience with PQI and how long have you been associated with it?
I think I've been associated with PQI ever since I came to CMU, or maybe a year after that.
Uh-huh.
And PQI is this brilliant sort of organization that maintains your interest in quantum information and quantum stuff in general, actually. And I attended all the PQIs except for one, maybe where I was traveling or something.
Okay.
But in each of these PQIs, the fun part is that they have a very broad spectrum of people from all sorts of different approaches looking at problems within quantum information, or you could just say quantum systems in general.
Okay.
And it gives you a very kind of broad view of the field that you're in. So it's very enriching to sort of just attend PQI and meet different people, and it really is kind of, I think it's a solid organization that I enjoy interacting with. I look forward to each PQI, actually.
Oh wow, that's nice to hear. So like, have you been to any seminars or like conferences, either as part of your PQI or probably part of CMU? And what is the major takeaway like?
The PQI conferences?
Yeah, it could be either PQI or like CMU.
Yeah, I attended quite a few, I think 2 or 3 PQI conferences. And each time I come back with, oh, those are very interesting problems that they're talking about.
Okay.
Maybe I should read some of that stuff.
Oh, okay.
And sometimes you are able to say, oh, this is somehow related to what I'm doing. Why don't I talk to these people and find out a little bit more? And
Okay.
so it really is a fun experience attending PQIs, and I enjoy them.
Oh, that's good. So lastly, like, is there any advice that you would like to give to students who would like to associate with PQI, and also someone who is applying for poster award next year?
Well, for the people who are trying to apply for a poster award or trying to sort of get one, I think keep trying. That's
Okay.
my one session, because I presented posters several times before getting an award. But I guess the point is that you have to try and sort of make things as simple as possible, so that it reaches a broad audience.
Okay.
That's I think the key difficulty
Okay.
sometimes.
Okay, so I think like I'm so like that. Thank you for like coming here and like giving some valuable inputs, and I'm so glad to have you here today. Thank you, Vikesh, for being here, and thank you so much for watching our program.